Hello students, welcome to the lecture series of 11th standard mathematics. Today we are going to start chapter number 2, which is Trigonometry Part 1. This lecture does not include the complete chapter. There are a few topics which is the domain and the codomain, or the domain and range of the trigonometric functions, which will be taught in the next video lecture. Today we are going to cover maximum portion of trigonometry part 1 apart from the topics that I mentioned now. Okay, so let's start with the lecture. A little bit of revision. So we know that we calculated the trigonometric functions in our school, that is the sine, cos, tan, cot, cosec, sec, etc. For the angle theta, which was an angle in a right angle triangle, like this. According to the figure that is mentioned on the left hand side over here, where we have a right angle triangle. Let's name the triangle ABC, where angle C is theta degree. Then the trigonometric functions for that angle C, which is theta, can be given as follows. Sine theta is nothing but opposite upon hypotenuse. Sin theta is nothing but opposite side upon hypotenuse. Cos theta is adjacent side upon hypotenuse. Tan theta is opposite side upon adjacent side. Therefore, we can also write it as sin theta upon cos theta, which comes out to be opposite side upon adjacent side. Then cosec theta is nothing but the inverse of sin theta. Sec theta is nothing but, not inverse, reciprocal of sin theta. Then sec theta is nothing but the reciprocal of cos theta, and cot theta is nothing but the reciprocal of tan theta. This is the basic trigonometry that we have all learnt in the school. Okay, now let us take a circle. So we have a circle over here like this on the left hand side of the page, and let the radius of that circle be r. Now depending on the point that we have on the circumference of the circle, we are going to define the trigonometric functions for that point. Okay, so what we are doing is, we are having a circle. On that circle, we are considering, on the circumference of the circle, we are considering a point, and depending on the coordinates of that point, we are defining the trigonometric functions. So let's see. Now in this figure, we have point P, and depending on that point P, we have the radius r. Which is from the center to the point P, like this over here. And if we draw perpendiculars on x and y axis, we can get the x coordinate of that point and y coordinate of the point, which are as mentioned over here, x and y. And this angle is the theta angle, which the radius vector of point P, the theta is the angle which the radius vector of point P makes with the horizontal x axis. Okay, now using the triangle over here, which triangle? Let me just mark it out. The triangle A, B and C. In this triangle, where the angle C is theta, sin theta is nothing but the opposite side, which is y, divided by the hypotenuse, which is r. Okay, similarly cos theta is nothing but the adjacent side, which is x coordinate of the point, divided by the hypotenuse, which is r. And tan theta is nothing but the y coordinate divided by the x coordinate. Okay, fine. So let's revise these functions a little bit. So what is sin theta? Sin theta is nothing but the y coordinate of any point divided by the radius vector of that point. Cos theta is nothing but x coordinate of that point divided by the radius vector of that point, and tan theta is nothing but the y coordinate of the point divided by the x coordinate of the point. Okay, now we have a circle over here on the left hand side, the circle on which we considered the point with coordinate x and y. Now we know that the equation for circle is radius square is equal to x square plus y square. Radius square is equal to x square plus y square. Now for you, in that equation, we can substitute x is equal to r cos theta from this equation, and y is equal to r sin theta from this equation, Okay, so what do we have? We have y is equal to r sin theta and x is equal to r cos theta. Now we have to substitute these values for x and y in the equation. R square is equal to x square plus y square. So in place of x square, we have r square cos square theta. In place of y square, we have r square sin square theta, and r square can be written as 1 into r square. So what we'll do, on all the sides we have r square, so we'll cancel that r square, which is basically dividing the whole equation by r square. Therefore we get an equation which is free of r. So what remains is cos square theta plus sine square theta is equal to 1. So this is the first trigonometric identity that you need to remember, which says cos square theta plus sine square theta is equal to 1. Remember, theta is the same angle. So when we are finding out cos theta and sine theta, they are to be found out for the same angle theta. Okay, chalo. Now let's move on further. Now, as we had earlier in this case, the circle over here, we had the radius as r. We had the radius as some r, value r. Now what we are doing is we are considering a circle of unit radius, which means that our r is now 1 unit. Our r is now 1 unit. Now substituting that r is equal to 1 in all the equations for sine theta, cos theta and tan theta, what do we get? We get sine theta as y, we get cos theta as x, okay, and what is tan theta? Tan theta remains the same. Tan theta remains the same. Now why we have done this exercise? The reason for doing this exercise is by using these formulas for sine theta, cos theta and tan theta in a circle of unit radius, what we are going to do is we are going to find out the signs. We are going to find out the signs of the trigonometric functions in different coordinates. Because we know as we go from first quadrant to second quadrant to third quadrant and to fourth quadrant, the x and y coordinates change their signs. Okay, so depending on that, the trigonometric functions will also be positive or negative. Okay, now let's look for the first quadrant. So in first quadrant, we know theta lies between 0 and pi by 2. Theta lies between 0 and pi by 2. So in first quadrant, let's draw the quadrants over here. So we have this is the first quadrant, this is the first quadrant. So in first quadrant, we can clearly see that x is positive as well as y is positive. Okay, so x is positive and y is positive. Therefore, sine theta, which is equal to y in a circle of unit radius, is also positive, and cos theta, which is equal to x, is also positive. Sorry, I wrote negative, but yeah, it's positive. Cos theta is also positive. Okay, so sine theta, that is y, is positive in first quadrant, and cos theta, which is equal to x, is also positive in first quadrant. Now tan theta, which is equal to sine theta upon cos theta, will obviously be positive because sine theta and cos theta are both positive in first quadrant. Okay, now let's move on towards the second quadrant. In second quadrant, which is this, the second quadrant, okay, we can clearly see that x is negative but y is positive. X is negative but y is positive. Therefore, sine theta, which is equal to y, is positive, and cos theta, which is equal to x, is negative. Now tan theta, which we know the formula for which is sine theta upon cos theta, is y upon x, and since x is negative, tan theta becomes negative. So in second quadrant, we have sine theta positive, cos theta and tan theta both negative. Okay, chalo. Now in third quadrant, the theta lies between 180 degrees and 270 degrees. So which is the third quadrant? This is the third quadrant. Clearly from the figure we can see that x is negative and y is also negative. X is negative and y is also negative. Therefore sine theta is negative, cos theta is also negative, but tan theta, which is sine upon cos, is positive. So in third quadrant, we have both sine and cos negative, whereas tan is positive. Okay, in fourth quadrant, the theta lies between 270 degrees and 360 degrees, which is this quadrant, the fourth quadrant. From here we can clearly see that x is positive and y is negative in the fourth quadrant. So x is positive and y is negative. Therefore sine theta is negative but cos theta is positive, and sine theta, which is sine upon tan theta, which is sine upon cos, is again negative. So in fourth quadrant, what do we have? In fourth quadrant, we have sine theta negative, tan theta negative, and cos as positive. Okay, so there's a trick to remember. So we draw the quadrants like this. We draw the x and y axis, and the quadrants like this are formed. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, so you need to remember the mnemonic all silver tea cups. All silver tea cups. So in first quadrant, all means everybody is positive. In second quadrant, silver, S, So sine is positive, cos and tan are negative. In third quadrant, T, that is tan, is positive and sine and cos are negative. In fourth quadrant, C, for cups. So C, cos is positive and sine and tan are negative. So you need to remember all silver T cups to remember in which quadrant which of the trigonometric functions are positive and which trigonometric functions are negative. Okay, fine. Okay, good. Now, the another topic that we are going to have a look at is the range of cos theta and sin theta. Range of cos theta and sin theta means basically the values that cos theta and sin theta can take. Range means values that cos theta and sin theta can take. Okay. Now, cos theta is equal to x and sin theta is equal to y when the unit circle, when we are in the unit circle, that is radius is 1. And we know the trigonometric identity cos square theta plus sin square theta is equal to 1. Therefore, x square plus y square is equal to 1, which is also the equation for the circle of radius 1 unit and center at origin. So, if x square plus y square is going to be 1, then x square should be less than or equal to 1 and y square should be less than or equal to 1. Right? When y square is equal to 1, x square is equal to 0. When x square is 1, y square is equal to 0. Correct? And when x square is less than 1, y square is also less than 1. Now, when we solve this inequality for x square less than 1, the value of x should lie between minus 1 and 1. And when we solve this inequality, y square is less than 1, the value of y should lie between minus 1 and 1. So, value of cos theta, which is x, lies between minus 1 and 1. Also can be equal to minus 1 and 1. Sin theta should also lie between and can also be equal to minus 1 and 1. Okay. So what are the values that sin theta and cos theta can take? The sin theta as well as cos theta trigonometric functions can take the values between minus 1 and 1, as well as they can also take the values of minus 1 and 1. Okay. So they both can take the values minus 1 and 1, including between minus 1 and 1, including minus 1 and 1. Okay, so sin theta and cos theta can take values between minus 1 and 1, including minus 1 and 1. Okay, good. Chalo. Now, let us answer this question that what if theta is changed to minus theta? What if theta is changed to minus theta? Now, theta, we know that we measure the angles in the anticlockwise direction. So, positive theta, which means that the arm of the angle is rotated in the anticlockwise direction with respect to the horizontal x-axis. Okay. On the other hand, minus theta or the negative angle means that the arm of the angle is rotated in the clockwise direction with respect to horizontal x-axis. Therefore, we have angle theta like this and minus theta angle as shown in the figure. Okay. So, sin theta is equal to y, cos theta is equal to x and tan theta is equal to y by x. These are the trigonometric functions that we have seen. Right. For angle theta in the first quadrant when the circle has radius equals to 1 unit. Okay. Now, corresponding to this angle minus theta, we have another point P dash. So, corresponding to point P for angle theta, for minus theta, we had point P dash. So, as point P corresponds to angle theta, corresponding to minus theta, we have point P dash. And the coordinates of that point P dash will be x comma minus y. Now, x comma minus y, why? Because the point P dash is nothing but the reflection of point P. It is the reflection of point P about x-axis. It is the reflection of point P about x-axis. Therefore, the x coordinate will remain the same, but y coordinate will become negative. Okay. So now, similarly, if you are finding out the sine, cos, tan trigonometric functions for minus theta, they will be as follows. So, sine of minus theta. So, for minus theta, the y coordinate is nothing but minus y. So, it will be minus y. And we know y is nothing but sine theta. So, it is minus sine theta. So, sine of minus theta is nothing but minus sine theta. Similarly, cos for negative theta is nothing but the x coordinate of that point, and x coordinate of that point is nothing but positive x. And we know that x is equal to cos theta. So cos of minus theta is cos theta. Okay, so sine of minus theta is minus sine theta, but cos of minus theta is cos theta. Okay, now tan of minus theta. Tan of minus theta is sine of minus theta upon cos of minus theta. Sine of minus theta is minus sine theta. Cos of minus theta is cos theta. So sine theta upon cos theta is nothing but tan. Therefore, tan of minus theta is minus tan theta. So sine of negative angle is negative of sine of the same angle when considered positive. So sine of minus theta is minus of sine theta. Cos of minus theta is cos theta, and tan of minus theta is minus tan theta. Okay, now let us do this exercise for the other trigonometric functions. So let's do it for cosec of minus theta. Cosec of minus theta is nothing but 1 upon sine of minus theta, and sine of minus theta is minus sine theta, and 1 upon sine theta is cosec theta. So minus cosec theta. Good. Sec of minus theta is 1 upon cos of minus theta, which is equal to 1 upon cos theta. Therefore, sec theta. Cot of minus theta is 1 upon tan of minus theta, which is minus tan 1 upon minus tan theta. So therefore, minus cot theta. Okay, fine. So let's revise a little bit that we have seen in the last topic. So sine of minus theta is nothing but minus sine theta. This is what we have got for sine when the angle becomes negative. Cos of minus theta is cos theta. Tan of minus theta is tan theta. Then we have cosec of minus theta is minus cosec theta. Sec of minus theta is sec theta, and cot of minus theta is minus cot theta. Okay, fine. Then we have seen that cos theta is nothing but the x coordinate of the point, sine theta is nothing but the y coordinate of the point, and tan theta is nothing but the y coordinate of point divided by x coordinate of the point. When the point is on circumference of a circle with radius is equal to 1 unit. With radius is equal to 1 unit. Okay, fine. So that was all about trigonometry basics and a little bit addition to what we have learnt in the school. The only topic that is remaining in the trigonometry part 1 is the domain and range of trigonometric functions. Domain and range of trigonometric functions. So we'll have a separate lecture, okay, a short lecture of 5 to 10 minutes on that topic, and then we'll finish the chapter of trigonometry part 1. So there will be one more video on the lecture part of trigonometry part 1, after which we'll solve the questions from the exercise of 11th standard Maharashtra State Board book. Selected few questions. Okay, chalo. Hope you enjoyed the lecture. Hope you liked the lecture. Thank you very much.